All right, cool. And we'll share, present to everyone. And there we go. Okay, cool. All right, sweet. All right, so today we're going to go over the many-to-many relationship. This is the last official class, really, where there's a lecture. Got one more class, but this is the last one with a lecture. So we'll go over many-to-many today. It's not, or it's a bit more complicated than what we've worked with so far. It takes a little bit to wrap your head around sometimes, but really once you get your head around it, it makes a lot of sense. So has everybody gotten to this point? Has everybody implemented this, or at least at the very least, have you implemented the one-to-many or one-to-one or one-to-many relationship on the other one? Yeah, cool. All right, so then this is just going to build on top of that, really. So if you did the prep work, we had a cheese menu. So the many-to-many is the ability to have one object associated with many of the other and vice versa. So with the cheese menu object, which is right here, cheese menu model. Actually, here, let's view it in the, why am I looking at that? That's much harder. I don't know if you can see it in here very well or not, but.
Is that a convention to just put both words together of what the two you're joining is?
Yeah. I mean, well, it's been my experience anyway. It's pretty common just to say what's in that table. It doesn't always make a lot of sense. We had a situation where we had schedules or schedule items, but we had 3 different objects that could use those schedule items. So we had 3 different tables. Yeah. So at that point, it didn't make any sense to call it, I don't know, company, unit, property, schedules. Like that just is too verbose. Doesn't make any sense. So instead, we just called it like schedule relationships. But in that case, that was also a little unique because we didn't have 3 different columns for all the different IDs. We actually did a little bit of finagling and used 2 columns or 3 columns, but then had a compound ID that told us what type of object it was, so we knew which table to look in. So it was a little bit different, but there's another example of why you would use many-to-many, because we had 3 different resources that could all use multiple menus. And so if you had corresponding IDs in all of those tables for everything that it could be related to, it would be just a pain in the butt. So instead you have a 3rd table that has its own objects that hold the relationship between all of the other objects. So really, that's all a many-to-many is where's cheese menus? Here we go. Can you guys see that? Probably not. Well, either way, our table is set up so that there's no primary key on this table. There's no need to. We're using cheese ID here and the menu ID, which will form a compound ID. These 2 together will be unique. So you can't have multiple entries with the same cheese ID and menu ID. You could have multiple entries with the same cheese ID as long as the menu IDs are different and vice versa. So these 2 together form your compound key. So, but that's all that's in there. It's just 2 columns in this particular table, a cheese ID and a menu ID, and that forms the relationship. If we look at the data, you can see right here, it's a little easier to view the columns this way when you view data. We haven't entered anything yet, but so that's the relationship. We have a cheese ID and a menu ID. If you look up in this table, all menus that have particular cheese, you could just look and query based on the menu ID, or the cheese ID rather, and you'd get all the menu IDs, and then you can query the menu IDs based on those that are returned from the previous query. Well, you can combine them, but anyway. So as far as the entity framework is concerned, we now have a cheese menu model, which represents that table. And it has the ID that would be used for the cheese, and then the cheese itself, and a menu ID, which is for the menu and the menu itself. And then in our DB context, we need to add that. We need to add our, so everybody got up to this point, right, where you have menus, cheese, and, well, not menus, because we haven't had that yet. We're introducing the new menu objects as well. But we need to add, oh yeah, so I guess I should probably go over that too then. So the menu has an ID and a name, and that's it. Other than that, it has a list of cheese menus that it belongs to. And then in the DB context, we need to add both of those so it knows to access them. This will be stored in the menu table. This will be stored in the cheese menu table. So we need both of those represented in the context so we can do queries on either one of them. And then we created a new menu controller. So this is going to look a little bit different because I experimented and actually, instead of writing it all from scratch, I let Visual Studio generate all of the actions to see how it decided to do it. And so it created a private read-only DB context and used the underscore underneath, which is actually a pretty common practice. If you have something that's used internally and only internally, put an underscore and it denotes that this is an internal, and usually it's read-only or controlled in some way, very strictly. You don't need this to be anything other than read-only. Does everybody remember what the read-only keyword does? I'll go over it just in case. And I don't even know why I ask. I'm just going to go over it. So the read-only keyword makes sure that this can only be written to once, and it's during instantiation. If you don't write to it during instantiation, or if you don't assign it during instantiation, you won't be able to assign it anytime else. So that's it. It just means that this is never going to change, which is good because we don't ever want to change this in runtime in this particular case. So this is our context. It gets set just like with the other controller. The context gets passed, and we have a DB context here. Or we assign it to the internal variable. So this is one of the new things that it did, or one of the different things. It uses the async keyword here, which we won't really get into too much, but just keep in mind this works the same way as synchronous as far as the syntax, except you're calling async functions like toList async, and you have to await it. But really all it does is allows you to run these things and continue to move, so you don't get stuck in you don't have to wait. The response time is much faster because it can continue to do other things. There is a slight disadvantage to that, though. If this takes a while, then you can get incomplete data, I noticed, but that's, I mean, kind of expected. So in this case, I don't think it really makes sense to use this, but maybe it does. Since I don't use this on a daily basis, maybe there are other ways to get around this. So then if we, oh yeah, so here's our index. So all we do is get our menus. This is because that's all that we're doing on the index. We're not using the relationships yet. We're only focusing on menus here. So an index, same thing we did with cheeses. Use the context to get the menus object and convert it to the list. And it knows internally menus is going to be pulled from the menus table. And we just convert it to a list, pass it to the view. And then in the view, where are we? Views, menu, index. Okay, so there's our link for create new, yeah. So we just have our, this is another thing that they did that was different. HTML display for name model and then model that name. Jake, is Jake here? Because he might be more familiar with that. He won't? Okay, cool. I didn't have time to experiment with this and see what all the nuances were with it, but and then we loop through every item, and then we have a link for the edit action, details action, add item, and delete, which this is pre-populated. So this was actually one of the cool things about that, allowing it to generate all the code. I added the add item. That one wasn't in there, but the edit, details, and delete were. So all it does is display the name of the menu, and then any of the items that are in there, or not the name of the menu, the header for the whatever the heck you call it, name. which is, where are we? Did I leave that as menu? Yes, I did. Where's models? Menu. Yeah, I didn't set that. Okay, cool. So then if we go back to our controller, it's always harder doing this on this laptop because there's no real estate. All right, so index, and then details is the same thing as like just calling, I think they had it as index with an ID passed, but they auto-generate an action called details, so I just left it that way. They do a couple different things. They make it nullable, they check if it's null, return a not found if it's not there, and then they have another async call using single, but they call single or default async. And I mean, it's basically the same thing they did single, where the menu ID equals the ID that was passed in here. If it returns nothing, it's not found. Otherwise, I guess I should probably actually make this so we can see all this. This looks so much better on a desktop. So we want to get all the items for the cheese menu. So we want to get the cheese menu context, include cheese, where the menu ID equals the ID that was passed in here, and then we're going to convert it to an async, or we're going to convert it to a list, and then return that in our view menu model, passing in the menu that we got and the items that we got. So the when we want to view all the details of that menu, we need to get the menu first, and then we use, and if that menu exists, we proceed further and query the cheese menus relationship table to get all cheeses whose menu ID equals that ID. Convert that to a list, and then we pass that into our view menu model. View model. So in our view model, it's that simple: a menu and a list of items. Cheese menu. And where am I again? Menu control. Cool. Oh, and then if we look at our details page, our view model is our view menu view model. Same thing he did. We're just setting the title to the name. We're looping through each of the items, which was the cheese menu items, and displaying the cheese name that's in there. And then we have another condition. If there are none, then obviously this will produce nothing because it's not going to loop through anything. And if it does equal, or if there's nothing, then we just say that there are no items. And then there's the edit and the index that was all pre-generated. So you can just click edit, which edits the name. But go back to menu controller. And then for the create of the menu, since we don't care about the cheese menus again, we're just dealing with our relationship between menus and cheeses. All we care about is the names, or the name of the menu that we're creating. Initially, we just return the view for it, which is just this, which has a name. Again, this was all pre-generated, so it's kind of nice that it did all this. Looks fairly good too. But it's just a standard form. Name, view model is our menu. There was no need to create a view model for this particular action because all we're doing is using the name field. There's nothing special about it. Set this up as HTTP-post, create. We're going to bind to ID and name of the menu that we're creating, and then model state is valid. Then we add the menu that we just passed in, and then save changes, wait the results, and this is the other one, redirect to action, which is kind of nice because this will obviously handle if you change the route of that particular action. You don't need to change anything, just redirect to action, name of index. So you just pass in the actual name of the method for that action, and it figures out the route. Otherwise, if it's not valid, then we return the menu. So, I mean, this is nothing new. It's the same thing we already did. This is just inserting a new menu. Edit's the same thing. Find the menu, If it's found, return it to the view for the edit. Works the same way as the cheese edit. It's nothing special there. And then, yeah, and then handle the result when it gets passed in. Again, same thing. Deletes, same thing. We've already dealt with that before. All right, so add item. This is where we want to add the cheese to the menu. You pass in the menu item. Again, they made it nullable. I left it that way because I like that actually, because it allows you to handle more options, more situations. If the ID is null, turns not found. Otherwise, it basically does the same thing that the other one does. It finds the menu first if the menu exists, then it proceeds. Then we get a list of cheeses instead of cheese menus, because we don't care about the relationships at this point. All we want to do is get all the cheeses that are available to add to that menu. So same thing as before, cheeses to list async, and then we add this to the add menu item view model, passing in the menu and cheeses. We add the add menu item view model. We have our menu. We have select list item, which we've all worked with before, which is just a list of cheeses. We have a menu ID and a cheese ID, which will be used on the return of that form whenever they hit submit it, post, passed in, and bound to these. Because we overwrote the basic constructor with no parameters, it's a good idea to just make another one. And actually you should in this case. And so we have another constructor that accepts a menu and cheeses, a list of cheeses. All we do is just create a new list with select items, loop through, get the ID of the cheese, convert to string, the name of the cheese. So again, this is nothing new. Everybody's done this before. This is just to create the list on the add item page so that you can see the cheeses you have available. And then we return that in the, or for the view. So if we go to the view and add item, super simple as far as the amount of code, but set the add menu item view model as the model for this view. Title, again, is just the name of the menu. But in this case, because we're passing that add view model or add cheese item, add item, whatever the heck it is, the add menu item view model needs to model.menu.name instead of just like model.name. And then we add a select that has the cheese ID, or that accepts a selection of cheeses, assigns a cheese ID. And then we have a hidden value because we're not going to be changing the menu ID at all. We just need to pass it back when they submit it. So we have a hidden input that accepts the menu ID. And then, of course, a submit button. And when that gets submitted, it's going to pass the cheese ID that was selected. It's going to pass the menu ID that was put in there in the first place. And then all it does is we grab those two things if it's valid. If something's missing, obviously that'll catch it. And then we get all cheese menu items because this is just a validation that we don't already have it. So we look at the cheese menus, grab all of them where the cheese ID equals the ID that was passed and the menu ID equals the menu ID. So we should only ever get one, really, because it shouldn't allow more than one. But if it already exists where these two conditions are met, cheese ID and menu ID equal the same IDs that were passed here. If we find any, and this count does not equal 0, we just skip over it, redirect to the details page. So this is another cool thing about the redirect to action. You can name of details action and then just pass in ID equals menu ID, and that's good to go, and it just passes it into the appropriate path. But if it's not found in here, we have no existing relationship between those two. All we do is just create a new cheese menu object and assign the cheese using query to the cheeses based on that cheese ID. Same with the menu using the menu ID. So we just grab the cheese from the database, assign it to cheese. Same thing with menu, add it to the menu field or property. So now we have a new cheese menu item. So that's our relationship right there. That's the thing that binds them together. And then all we do is just add it to the cheese menus in the context, save the changes, and our relationship exists. So all it really is with the many-to-many is there's just a third item there that manages the relationship between the two. And now if we run this, everything should, I say should. I chose the wrong one. Anybody need me to go over any of those things in particular? Again, I kind of speed through a lot of this stuff because I figured there'll be more specific questions towards the end, but you all have been like super sharp on this stuff too, so at home. You can create a new menu. We've got menu 1, detail 1, then there's nothing in there. We don't have any cheeses either, so let's add cheddar. Oh, I forgot to finish that part of it. Don't worry about it. I haven't added any of that stuff. Let me add my categories. This is on a new computer. I was actually doing all this with my other one. I forgot to add this stuff. Sorry about this, guys. Oops. All right, cool. There we go. All right, cool. So we got 2 cheeses. We go to the menu. Got a menu 1 that we already added. We click details. There's no items. Back to list. We add an item. Got a list of our cheeses here. We add. Now our details. It redirects us back to our details. And there's our cheese that we added. Add another one. That has both. We add another one and try and add the same one. It just redirects back because it's already found the cheese in there. So it doesn't add a duplicate entry in there. And that's as simple as it can possibly get, really. This is a very quick example of how to make the many-to-many relationship. It's just some third object that between the two. Do we have any questions?
Can you pull up in Visual Studio where it shows the tables and maybe show the data in all the tables?
Sure.
That helps me figure out what's going on.
Yeah. Can I zoom in on that? I don't think I can.
So I'm guessing just in the background, it knows that it's a join table. As soon as it gets stuck from 2 tables, it just knows.
No. No, because it's not getting stuff from 2 tables. You're creating the relationship when you do in the menu controller. You're creating the relationship right here when you create a new cheese menu. And you assign it a cheese and a menu. It knows where these objects, these types of objects reside, but it's not getting information from the 2 tables. You're telling it, this is the cheese object that belongs in this, and this is the menu object that belongs in this. And then it inserts the IDs when you save this. So when you tell it in here, where is it? Delete details. Where's my details? Details.
When you say it, you're talking about the framework. Or you're talking about
Yeah.
that?
Right, the framework, yeah. Yeah. So when you get the details, you've already got the menu, so you don't need the menu. So you do a query on the cheese menus telling it you just want the cheese, where the menu ID equals this menu ID. So again, it's not automatically pulling the data. You're just telling it, because it knows what the object types are, but you're just telling it, here's what I want you to do. So it doesn't pull everything on its own. You're telling it exactly how to do it. Saying, I want you to query the database, return all cheeses in this database for cheese menus, return all objects, or return the cheese column of all objects where the menu ID equals this menu ID. And then if you did it on the other way and you had cheeses and you wanted to see all menus that cheese existed in, you would do the same thing, just opposite. So you would say return all menus where the cheese ID equals this cheese ID. And then that would give you all of your menus back. So that's really all it is. It's not magic in that it already knows the relationship between everything. You're kind of telling it how. I mean, it has IDs and it knows what the object types are, but you're still kind of doing the work, telling you exactly what you want to get. So in here, you're actually saying, create a new relationship. We just happen to call it cheese menu. And here's the cheese, and here's the menu that exists for it. When you add it to the DB context and tell it to save, it knows to grab the IDs from those two things and stick them in the columns, the corresponding columns. Does it make sense or no? Okay. All right, cool. Any other questions? Make it pretty clear for everybody? Cool.